Hello everyone. In this lecture, we are going to study the force exerted by jet on the hinge plate. Now, in previous lecture, we have studied the force exerted by jets on the stationary plate. That stationary plate is either vertical or inclined or the curved one. Okay. As I have already explained, this whole thing we have to study because we have to design some water resources structures. Okay, so the force exerted by jet on hinge plate can be calculated by following manner. I'll explain one by one. Let this consider this diagram first. In this, you have familiar with this pipe and nozzle. Now this through this nozzle, a jet of water is striking on this hinge plate. Okay. Now this plate is hinged at the O, at one end at the O, and another end is free to swing. Now the angle theta is nothing but your angle of swing. This angle is your angle of swing. This dotted portion shows that this plate, square or rectangular plate, is initially at this position. Whenever the jet is striking this plate, what happened? This initial position shifted to this position. Okay. Now, when the whole plate, after striking the jet, when the whole plate is in equilibrium, what happened? The moments of all the forces which are acting on this plate must be zero. Okay. Now consider this position of point A. This point A is shifted to next position, that is A dash. Okay. At this A dash, the weight of plate W is acting. Okay. Now, and uh, if we look at this figure carefully, we can see that this jet is striking exactly this inclined plate. Okay, so as this is an inclined plate, a normal or perpendicular force is acting on this plate. This thing we have studied in the force exerted by jet on inclined plate. That is, we already had calculated the normal forces and then derived the two components of this normal force, that is Fx and Fy, in the direction x and in the direction y. Now here, after the equilibrium of this hinge plate, there are two forces which are acting on the plate. First is your weight of plate W, and second is normal force or perpendicular force Fn. Okay. The weight of this plate W, it is acting at A dash, that is the center of gravity of the plate. Okay. Now consider the distance of this A dash from hinge O. From the figure we can see that here O to A distance is x, and again O to A dash distance is x. That means OA equals to OA dash equals to your distance x. Okay, and the h is nothing but your height of whole plate. Now we can consider this triangle for calculation of moments. Now in this whole thing, we have to calculate the angle of swing of this plate. Okay. Now if you remember the normal force, that means the Fn perpendicular force for the inclined plate, we are going to calculate the angle theta, that means the angle between the jet and the plate. In case of inclined plate, we have already studied that Fn is equals to rho a v square sine of theta. Okay, sine of theta, but that theta is nothing but the angle between your jet and angle between your plate. Here in this diagram we can see that the angle between jet and plate is not given. The angle of swing for the hinge plate is given. So from this angle we have to calculate the angle between jet and plate, that angle is nothing but your sine, sorry, 90 minus theta. Okay, now take the moments of these forces, that is W and Fn perpendicular about the O. This is your hinge. I'll highlight this. Okay, this your hinge. The moment about O of W and the moment of normal force Fn about O, we have to calculate. From that we can get the angle of swing, that is theta angle we can get. Okay, now for calculation of moments about hinge, first we have to calculate the normal force. Okay, Fn, what is the formula for Fn? Fn is nothing but the force due to the jet of water normal to the plate. Fn equals to rho a v square sine of theta, but here theta is angle of swing, so we have to take theta dash. Okay, theta dash. Now I'll show you the formula here. Theta dash, Fn equals to rho a v square sine of theta dash. That theta dash is nothing but your 90 minus theta, sine 90 minus theta. Rho a v square sine 90 minus theta will be your Fn. Okay, now secondly, the moment of weight of plate we have to take. Okay, now the calculation of moment of forces Fn about the hinge is Fn into Ob. This is easily understand by your diagram only. Okay, now Fn, this force into the perpendicular distance from hinge is O to B. Okay, but the value of OB is not given. We have to calculate this OB. From the angle theta, we can calculate the value of OB. This OB, if you see the triangle, if you see the triangle OAB, we can see that the OB is nothing but your hypotenuse. Okay, OB is nothing but your hypotenuse and AB is nothing but your opposite side of theta, and OA is nothing but your adjacent side of theta. Okay, here we have to calculate the hypotenuse, that is OB, distance OB. Okay, now from the formula we can here see that sine 90 minus theta is nothing but your cos theta. Sine 90 minus theta is nothing but your cos theta. So we have to convert this OB into cos of theta. OB into cos of theta, so that we can cancel this cos theta, and we can simply write the values, numerical values of some quantities here. Now this OB can be written in the form of cos theta. How we can write this? The angle theta, adjacent side and hypotenuse. Okay, that means cos of this theta will be equals to OA, that is adjacent side, upon hypotenuse, that is OB. Okay, OB. So OA upon OB equals to cos of theta. That means OB equals to OA upon cos of theta. OB equals to OA upon cos of theta. So that this cos theta and this cos theta will get cancelled, and rho a v square OA will be your value of Fn. Now this OA is given as value x. So the final answer is rho a v square into x. Okay. Now the moment of W, that means your weight about the hinge. This can be calculated by same manner, the weight into your perpendicular distance, that is A to A dash. This A to A dash. This distance we have to calculate again by same manner. That means by using the angle theta we have to calculate this perpendicular distance. As this side is opposite to theta, the equation will be of sine. Okay, equation will be of sine angle. So here it is written as W into OA dash sine of theta equals to WX into sine theta. This thing, as I have already explained, OA equals to OA dash equals to X. So I have directly written here X and sine of theta. For the equilibrium, this both the moments should be equate. So rho a v square x into equals to must be equal to wx sine of theta. From this whole equation we can get the value of angle of swing of the hinged plate. Okay, now second thing is, when we are studying the stationary plates, we we have not calculated we have not calculated the angle of swing. Okay, why? Because that plates are stationary. Okay, so that we have calculated the forces acting on that plate. That forces we can use in this hinge plate. Okay, that forces we can use in this hinge plate. So I have used the force exerted by plate on incline direction. Okay, when that plate is inclined. When the plate is vertical, we can use that formula for vertical plate also. Here we'll solve some numericals. First is a jet of water of 2.5 centimeter diameter moving with a velocity of 10 meters per second strikes a hinged square plate of weight 98.1 newtons at the center of plate. The plate is of uniform thickness. Find the angle through which the plate will swing. Here, what are the given quantities? Given quantities are the diameter of jet, that is 2.5 centimeters, and the velocity with which the jet is moving. That velocity is 10 meters per second. That means your V is 10 meters per second. Now, the weight of the plate is 98.1 newtons. Here, the weight is given in your Newton unit. At the center of plate, that means the center of gravity, the center of the plate is of uniform thickness. That means the plate is not tapered, or it is not of some different thicknesses. It is of uniform thickness. Find the angle through which the plate will swing. That means you have to find out the sine theta value. Now here the diameter of plate, diameter of jet is given in centimeters. We have to convert this in meter, because the weight of plate is given in your newtons and velocity is given in meters per second. So we have to take all the quantities in same unit system. So velocity of jet given is 10 meters per second, and weight of plate W equals to 98.1 newtons. From the diameter of your jet, we can calculate the area of jet. We can calculate the area of jet, that is pi by 4 d square. The value is 0.00049 meters square. This is a very simple example. The angle through which plate will swing is, as I have right now I have explained this, sine theta is rho a v square upon w. Here the value of rho nothing but the value of water. A, we have calculated area. V square, they have given the velocity of jet, and w, that means the weight of plate also they have given. So putting all the quantities on this in this equation, that means 1000 into 0.00049 into 10 square upon 98.1, we get the value of sine theta. Okay, but we have to know the value of theta only. So convert this sine theta into theta, that means sine inverse of 0.499 can get 29.96 degrees angle through which that plate is swing from the original position. Okay, that example is very simple. Now, second example, a jet of water of 30 mm diameter strikes a hinged square plate at its center with a velocity of 20 meters per second. The plate is deflected through an angle of 20 degrees. Find the weight of plate. Here what they have given, angle of swing they have given, velocity they have given, and we have to find out the weight of plate. Okay. Now, secondly, if the plate is not allowed to swing, what will be the force required at the lower edge of the plate to keep the plate in vertical position? Here, what is the second condition? Second condition is when the plate is strikes with the jet, obviously it will move. Okay, but if the plate is not allowed to swing, what will be the value of force uh, that we have to act on the lower edge of that plate to keep that plate in vertical position? Okay, so firstly we have to find out the W, and secondly we have to find out the second value of that force. Now, they have given diameter of jet, that is 30 mm. We have to convert this in meters, 0.03 meters. From that we can find out the area. Okay, area of plate, velocity they have given, and angle of swing they have given. So the weight of plate can be easily calculated by final value or final formula of angle of swing, that is sin theta equals to rho a v square upon w. Area value we have calculated, velocity and angle of swing. Put this all quantities in the formula sin theta equals to rho a v square w. We can get the value of w by simple mathematical calculations as 826.6 newtons. Okay, as the whole quantities or all the quantities are in meters per second, the final value of w will be in newtons. Okay, now the second condition, look at this condition carefully. What they have considered here, we have to fix this plate. Okay, that means if the plate is not allowed to swing, what is the value of force that will be applied at the lower edge of the plate? Here the value of P, the force P is allowed at the lower edge of the this hinge plate. That means if the water is striking at the force F at this point, water is striking at the force with the force F, then we have to equate this force with the P. Okay, so again what happened, the weight of plate is acting vertically downward, okay, through the center of gravity of plate, where the weight is acting center of gravity of plate. So that what happened, the moment of this W will be 0 because it is acting in the same line that hinge is placed. Okay, so consider this F, this will be your F, that means the force exerted by jet of water, and H is nothing but your height of force P or distance of force P from the hinge. Hmm? Now we can see here that the force F, that means the force exerted by jet of water, that force is acting at the distance half of the this height, that means h by 2. The jet strikes at the center of the plate, and hence the distance of center of jet from hinge is h by 2. Now we can take the moments of these two forces, that is F and P. Okay, first take the moment of P. As both the moments are in opposite direction, we can equate these moments. F into h by 2 equals to p into h. Okay, p into h equals to f into h by 2. Now p will be f into h upon 2h. The h will get cancelled. Remaining value is f by 2. Now here I have written as rho a v square. Why I have written here rho a v square? Because this jet is striking the vertical stationary plate. Okay, this jet is striking the vertical stationary plate, so the value of F will be rho a v square, that is the force exerted by jet on a stationary vertical plate. This thing I have studied, we have studied in first lecture, that is force exerted by jet on these stationary plates. Okay, consider all the quantities in this equation and find the value of p, that is the force which we have to apply on the lower edge of hinge plate to remain that plate in the vertical direction only. Okay, I hope you understand this numerical. And this numerical is very simple. The thing is that we have to consider all the formulas related to stationary vertical plate also, stationary inclined plate also, and the hinge plate also. Okay, next numerical, this is the last numerical on hinge plate. Okay, this is same as we have studied. Now, a jet of water of diameter 25 mm strikes a 20 centimeters into 20 centimeters square plate of uniform thickness with a velocity of 10 meters per second at the center of plate, which is suspended vertically by a hinge on its top horizontal edge. The weight of plate is 98.1 newtons. The jet strikes normal to the plate. What force must be applied at the lower edge of plate so that plate is kept vertical? Okay, first thing is uh, they have given the diameter of jet of water and the square plate dimensions are given, that means height, width, etc. And they uh, says that the plate is of uniform thickness. Okay, now the velocity of jet is 10 meters per second, and the plate is hinged one or at the top horizontal edge. Now the weight of plate is also given 98.1. We have to find out the same thing which we have previously explained. We have to find out the force which must be applied at the lower edge of plate so that that plate is kept vertical only. Okay, and secondly, what happened, if that plate is allowed to deflect freely, what will be the inclination of plate with vertical due to the force exerted by jet of water? That means here what we have to find out, sin theta value, and here we have to find out the value of external force which we have to add or which we have to be acted on the lower edge of plate. Okay, from these two conditions we can say that the second condition is more easy to find out, so we can first find out the angle of swing. Okay, or we can find out the angle, we can find out the force P also first. So let's find out the value of P. Here they have given diameter of jet as 25 mm, so we can convert this in meters. 25 into 10 raised to minus 3 mm can be converted into meters by multiplying 10 raised to minus 3. From this, area is pi by 4 d square. Now the size of plate they have given as 20 centimeters into 20 centimeters. From this information, I have drawn a diagram. Here you can see here that the velocity v with which jet is acting and the force F with which is acted on the plate by the jet. This is your hinge and this is the plate. The force Fn or F acted and at the distance 10, because the whole height of this plate is 20 centimeters. Dimensions is 20 into 20. So this whole height is 20 and F acted on the half of this height, that means 10. And this force P, this external force I have added here. Now, the weight of plate they have given as 98.1 newtons. Velocity of jet V is 10 meters per second. Now, first we have to find out the force which is acted at the lower edge of plate to keep this plate in vertical position. This, as this diagram shows, if we add this force P, the whole plate, hinge plate, will be in vertical direction. Okay. So the force F exerted by jet of water at the center of vertical plate will be equals to the force exerted by jet of water on a stationary flat plate. That means F equals to rho A V square. I am repeating this because this thing we have already studied in previous lecture. We have to sum up the all formulas. I'll give you a PDF of all the formulas so that you can easily understand. So put all the quantities in the formula, that means rho value, A value and velocity value. You can get the value of F. F is 49 kilonewton. To equate this, the force, we have to take the moments of all the forces about hinge. So first, this force is acting, that means Fn is acting at the distance of 10 centimeters, that is half of your height. Okay, half of your height. This 49 is acting at the 10 centimeters, and the force P, that is external force, is acting at the distance of 20 centimeters. Okay, this this is your F and this is your P. Okay, and the at this edge the hinge is acting. Now take the moments. Moment will be F into 10 equals to P into 20. So F value is 49. We can easily calculate the value of P. P equals to 24.5. So to uh, to keep this plate stationary along with 49 newtons, we have to add additional 24.5 newton force at the lower end of hinge plate, so that this plate can be stay vertically straight. Okay, now the second question is, what will be the angle of swing if the plate is allowed to deflect freely about the hinge? That means this is your condition of hinge plate. Okay, we have to here find out the value of sine theta. Okay, let the inclination of plate with vertical is theta. Okay, this angle is theta. In this position, the angle between plate and jet will be 90 minus theta. These things I have already explained. The angle between jet and plate will be 90 minus theta. Now the force exerted by the water normal to the plate will be equal to Fn. Fn equals to rho a v square sine 90 minus theta. That means rho a v square cos of theta. Okay, the formulas are repeatedly appearing here. Put the values of all the quantities, but for this, firstly, what theta is not given, so we have to convert this cos theta into some numerical values. Okay, so convert this Now the for the moment we have to take the distance O to B, this O to this B, and this Fn is acting at the distance OB from hinge. So we have to convert this OB in some numerical value 2, so that this cos theta and this cos theta will get cancelled, and some numerical value which we have, which we want, that will be stay here. The distance OB equals to OA upon cos of theta equals to, the value of OA is 10 centimeters, it is half of your height, 10 upon cos of theta. Okay, the weight W, again the weight W of this plate is acting at the distance 10 centimeters from this hinge. Okay, the distance DG, this distance will be the perpendicular distance for the moment of this W. So this DG can be converted into OG into sine of theta. That means this hypotenuse into sine of theta. Okay. Now the things are given. Now take the moments of all two forces about the hinge. That means Fn into OB equals to W into GD. Put all the quantities and find out the value of theta. Theta equals to, that means sine theta, firstly sine theta equals to 0.5 and theta equals to 30 degree. That means sine inverse of half equals to 30 degree. Okay. This example is also somehow same, so that I'll not going to explain this example. I'll show you the PDF of this example. Now moving towards the moving plate. Okay, firstly, in previous ones we have studied stationary plates. Now in this video we have studied hinged plates. Now this one is the moving ones. Okay, the force exerted by flat vertical plate moving in the direction of jet. Now as this plate is moving and vertical plate, we have to find out the force exerted by the jet on the plate which is moving and vertical, not inclined one, which is moving and vertical one. From this diagram, consider this diagram. Here the jet of water is striking on this plate. This plate is initially at this position, but when the jet is striking, what happened, as this plate is not fixed, you can see here there is no any support at the lower, at the edge of at both the edges of this plate, there is no any support for this plate, so that this plate is moving one. Okay, whenever the force or jet is acting with some force at this plate, what happened, this plate will move further. Okay, from this position to this position. Now again what happened, suppose the jet of water is acting with velocity v, that is your absolute velocity v. What happened, the plate is also moving with some velocity, that means the velocity u. Okay, now what will be the final velocity of your water, that means relative velocity. Relative velocity will be absolute velocity minus the velocity of plate. Okay, that means v minus u. I hope you understand. That means here I'll explain. In this case, what happened? The jet does not strike the plate with velocity v, but it strikes with relative velocity. As I have already explained, the relative velocity with which the jet strikes that plate, okay, which will be equal to the absolute velocity of jet of water minus velocity of plate. That means v minus u. Okay, relative velocity ये इजी कंसेप्ट है. इसमें क्या होता है कि जो जिस वेलोसिटी से आपका जेट स्ट्राइक हो रहा है वो वेलोसिटी माइनस क्या आपकी प्लेट की वेलोसिटी है. जो भी वेलोसिटी आपकी प्लेट की है वो वेलोसिटी क्यों आती है, प्लेट को वेलोसिटी क्यों आएगी, क्योंकि जो जेट है वो प्लेट पे स्ट्राइक होगा. ओके, तो at the moment of striking, the velocity is your relative velocity. Okay, but before that, the velocity with which jet is moving, that velocity is v. The velocity with which plate is moving, that velocity is u. Okay, so the relative velocity will be your absolute velocity of jet and the velocity of plate. The difference of both this will be equal to the relative velocity. Okay, hope you understand this relative velocity concept. Now move further. This is very simple. We have already studied your impulse momentum equation. That momentum equation, impulse momentum equation, we have to apply here also, as in the case we applied in the stationary plates, we have to apply same for the moving plates. Here, mass of water striking the plate per second will be rho a v. Okay, this thing I have write in separate because here velocity is somehow changed. So rho a into your relative velocity we have to take, that means v minus u. Okay, now secondly, force exerted by jet on a moving plate in the direction of jet will be Fx. Okay, Fx will be uh, rate of change of momentum. Okay, rate of change of momentum, that means mass of water striking per second into velocity with which water is striking minus final velocity. Now in the direction of x there is no any final velocity of the jet, so there is only initial velocity, that means your v minus u. So put that quantities rho a v minus u into bracket v minus u minus 0. So this will be the multiplication. Fx is rho a v minus u bracket square. Now what happened in case of this moving plates? We have to find out the work done. Okay, we have to find out the work done because there is some velocity for the plate also. Okay, now in stationary plate what happened, there is no any work done because there is uh, plate is not moving there. Okay, so here what happened, plate is move, as the plate is moving there will be some work done by the jet on plate. Okay, so work done can be calculated as force into the velocity, that means distance in the direction of force upon time. Distance upon time is nothing but your velocity. So force Fx into u. Fx we have already calculated, rho a v minus u bracket square into the velocity of plate is u. Here I have taken velocity of plate because work is done by jet on the plate itself. So here the velocity of plate is taken, that means u, and you have already know that the unit of work done is Newton meters per second. Okay, now secondly, force exerted on inclined plate. The previous plate is vertical, this plate is inclined one, and obviously the plate is moving also. Okay, now consider this diagram. Here the same velocity v, with which jet is moving, and the u is nothing but the velocity of plate with which it is moving. As this strikes on this plate, what happened, this plate moves to this position, dotted position. Okay, and the relative velocity will be your u minus v minus u, that means velocity of jet minus velocity of plate. Okay, now again this angle is theta. Okay, these things you have already studied in the stationary plate phenomenon. Okay, here I have listed that v is your absolute velocity, u is the velocity of plate, theta is the angle between jet and plate, and cross sectional area of jet is your a. Okay, now mass of water striking per second is rho a v minus u. Again, the thing is that plates, all plates we are going to consider are smooth plate. Therefore, there is no any loss of energy due to the impact of jet. That means there is no any loss of friction, no any loss of entrance or openings. So minor losses are negligible here. So we are assuming that plates are very smooth. Okay, and the velocity with which the jet of water leaving that inclined plate is nothing but v minus u. Okay, now we are going to calculate the forces. Here, if you remember, for the inclined plate, firstly we are going to calculate the normal force. Okay, that is perpendicular force with which jet is acting, and then we are going to divide that force into fx and fy component. Okay, so firstly calculate the force, normal force with which force is exerted by the jet on the plate. Okay, Fn equals to mass of striking water per second into initial velocity minus final velocity. Okay, now in normal direction, initial velocity will be v minus u sine of theta. Okay, and your mass is rho a v minus u, and there is no any final velocity. So rho a v minus u bracket square sine theta will be your normal force. Okay, now this normal force can be resolved into two components, fx and fy. Now fx will be here, fx will be fn sine theta, and fy will be fn cos theta. This is very simple geometrical calculations, because I am not going to explain this in this video, because I have already explained this in your incline stationary plate video. Okay, now components will be fx fn sine theta, and fy will be fn cos theta. Put the value of fn in this, and we'll get two components, rho a v minus u square sine square theta and rho a v minus u square sine theta cos theta. Okay, now again we have to find out work done, as this plate is moving. Now work done in which direction? Work done by jet on the plate in x direction, that means in the direction of jet. So fx component we have here, uh, taking fx component, that means fx into distance per second in the direction of x, rho a v minus u square sine square, this is the formula for fx, and the velocity we are going to take is velocity of plate. So sum up this and calculate the work done. Okay, you will understand easily this by numericals. First numerical, a jet of water of diameter 40 centimeters strikes a flat plate normally with a velocity of 15 meters per second. The plate is moving with a velocity of 6 meters per second in the direction of jet and away from the jet. Find force exerted by jet on the plate and work done by jet on the plate per second. Very simple example. The thing is that you have to know all the formulas, and uh, you have to know all the things related to vertical stationary plates also and vertical moving plate also. Okay, here they have given the diameter of jet 10 centimeters, velocity of jet is 15 meters per second, and the velocity of plate is 6 meters per second. They have not given the angle of inclination, and they given that the plate jet is striking normally to the plate. Okay, so this is the condition of force exerted by jet on moving vertical plate. Okay, from the diameter, convert the diameter into meters. We can calculate the area. A equals to pi by 4 d square. From this, area is 0.007854. Now the velocity of jet V will be, velocity they have given, the jet velocity is 15 and plate velocity is 6. So relative velocity will be 15 minus 6. Okay, the force exerted by jet on moving flat vertical plate is Fx. Fx will be rho a v minus u bracket square. If this is not moving, then what will be the formula? Rho a v square only. Okay, rho a v square will only. Here the plate is moving, so only the thing is this velocity is relative velocity, so v minus u I have taken as this plate is moving. Okay, put all the values, that is rho is 1000, a we have calculated, velocity of jet is 15 and velocity of plate is 6 into bracket square. The value of force will be 636.17 newtons. Here again we have to find out the work done per second by jet. Okay, now as I have already explained how to find out the work done. Work done will be your force into distance divided by time. That means your velocity of plate. As this work done is by jet on plate, here we have taken the velocity of plate. So Fx is 636.17 and velocity of plate is 6. Multiply these quantities, you'll get the value of work done in Newton meters per second. You can justify this unit also. Here the value of Fx is in newtons, and you know that the velocity unit is meters per second. So by multiplying this, the unit will be Newton meters per second. If you forget that the work done unit is Newton per meter square, you can simply use this concept also. Now the second example. Second example is a plate 7.5 centimeter diameter jet having a velocity of 30 meters per second strikes a flat plate, the normal of which is inclined at 45 degrees to the axis of jet. Find the normal pressure on the plate. First, when plate is stationary, and second, when plate is moving with a velocity of 15 meters per second and away from the jet. Also determine the power and efficiency of jet when the plate is moving. This is also very simple, but the thing is that here the plate is inclined one. Okay, and two conditions we have to solve. Firstly, inclined stationary plate, and second is inclined moving plate. Okay, they have given the diameter of jet 7.5 mm and the velocity of jet is 30 meters per second. Okay, and the inclination angle is given 45. So angle between jet and plate we have to find out by 90 minus inclination angle. So From the diameter of jet, area of jet can be calculated as pi by 4 d square, and the angle between jet and plate can be calculated by inclination angle 90 minus inclination angle, that means it is 45 degree. And the velocity of jet they have given as 30 meters per second. Now, when first condition is when the plate is stationary. Now, when the plate is stationary, the formula for inclined normal force is, they have uh, again specified that we have to only find normal forces. Okay, that means Fn only we have to find out, not Fx and Fy. So, for the normal force when plate is inclined stationary, the formula is rho a v square sine theta. Okay, put all the quantities in this formula, will get Fn value is 2810.96 newtons. And secondly, when the plate is moving with velocity of 15 meters per second, that means the velocity of plate is 15 meters per second, the normal force will be rho a v minus u bracket square sine theta. You can see here only the difference is, here only v is there and here v minus u is there. That means here your absolute velocity is given and here relative velocity is given. Okay, by considering all the quantities you will calculate the value of normal force here also. And second thing is, you have to find out the power and efficiency of jet when plate is moving. Okay, how to find out the power? First, for that you have to find out the work done by jet. Work done by jet, we have to find out the fx and the uh, velocity of plate. Okay, fx can be easily calculated by fn sine theta will be your fx. So fn we have already calculated, so put that fn value here and sine theta value here, you will get the value of fx. So from this, the work done will be fx into u, that is 7453.5 newton meters per second will be your work done. Now power, for this, power is work done upon 1000. Okay, this is your familiar formula, that means power in kilowatt will be work done per second upon 1000. Okay, you will get the power in kilowatts, and efficiency is nothing but, this is also a usual formula, efficiency is nothing but your output and what input you have given to the machine, some machine. Okay, output is nothing but your work done per second, and input is nothing but the kinetic energy of jet. Okay, kinetic energy of jet means the energy with which that jet is moving is nothing but your input that you have given to the plate. Okay, and output is nothing but the work done by that plate. Okay, work done on that plate. Now, work done we have calculated, and the kinetic energy formula is nothing but half mv square. Okay, m is nothing but rho a v mass per second, rho a v into v square. So by simple mathematical calculation, we can get the efficiency as 12.5%. Okay, always remember that we have to find out the efficiency in percentage only. Okay, how much percentage efficient is that machine, we have to find out. Okay, any machine efficiency, in any machine efficiency is given in percentage only, and the power is in kilowatt or watt. Okay, for that, firstly you have to find out the work done. Okay, remember all this formula, I'll sum up these formulas for you and send a pdf to you. So you have to remember all the formulas for stationary plates, moving plates, and the hinge plates. Okay, the connection in between this you have to remember very well. Thank you.